coin is tossed in the air and follows the path shown in panel A. In which panel B or C do the arrows correctly show the forces acting on the upward and downward parts of its trajectory? So the answer choice would be C, because there is no force due to its motion. Unless we consider drag, which would also point in the same motion for its upward motion as the force of gravity. So it would point downward for drag, but we can ignore it since we're assuming it's going at a slow enough speed and the change of height is small enough. So for its upward motion, it would only feel force of gravity. At its point, it would feel no upward force because all it had was momentum. On its downward trajectory, it would feel downward force, and there would be no other forces in its system due to the system.
Alright. That was the first one. Nice. Here's the second one.
Suppose you are trying to get a hockey puck to travel along the track as shown in the picture. At the beginning, somebody hits it in the direction shown. Which direction? I. In which direction A, B, or C does somebody hit it so the puck makes the first turn? 2. In which direction A, B, or C does somebody hit it so the puck makes the second turn? If we assume conservation momentum due to its initial motion, it has upward motion. So we would want to give it some rightward motion, and if we assume its motion upward is not changed due to our force we apply, or the hit, we would only need to apply a force perpendicular to it to cause it to move diagonally, if it is at a 45-degree angle. So for I, the first answer choice would be B. If we assume we change its momentum entirely, we would go with A, but the correct answer choice should be B. For its second motion, it would kind of follow the same situation. We would instead want to counteract we would want it to move more rightward and no longer to move upward due to the upward motion. So we would either put force C or B, which in this case, you would lean more towards C, which would cancel out its initial upward motion.
Okay. So for the first turn, which one did you choose?
B.
And the second turn?
C. Assuming that its trajectory in the hit we do does not affect it in its perpendicular axis.
Alright, awesome. Okay, third question.
Under normal atmospheric conditions, an object is placed in a scale and reads 10 pounds. If the scale and object were placed under a glass dome and all the air were removed from under the dome, what would the scale read? If we assume the gas it was in was just pure air, it would still be under the effects of gravity because we haven't removed it from the system of the Earth. So it would still weigh 10 pounds.
Alright. Last question.
An object weighing 1 kilogram in normal air takes 1 second to fall at distance Z. How long will it take an object the same size but weighing 5 kilograms to fall the same distance? It would still take 1 second because its acceleration due to gravity is independent of its mass. Only the force it feels would be dependent on its mass. So it would accelerate at the same rate, assuming they are the same size. They are the same size, so it would fall in 1 second in the same distance, as long as the air is the same and all other things are kept constant.
Alright, thank you.
Subject A showed impressive cognitive skills.
Alright, here's the first prompt. Go ahead and read it aloud and then get started.
Okay. A coin is tossed in the air, followed by the path showing in panel A. In which panel B and C do the arrows correctly show the force acting on the coin on the upward and downward parts in the trajectory? Okay, sorry. What happened to it? It's going up.
What are you thinking?
Oh, right now I'm just rereading the problem because sometimes I read it wrong. Well, I'm looking at panel A, and it's saying that it's just going up, going up, going up, till it finally hits its like maximum angle, I guess, and then it begins to fall. And then panel B shows it's going up, but it also shows that gravity has an effect on it, which is also holding it back a little. And then figure C shows it's going up, and I guess gravity is holding it down. And I just choose the answer, right?
Yeah, which one do you think is the right answer?
If I had to choose on it, I would go with B.
Why?
Because everything seems to be going right because it goes up, but then gravity eventually pulls it back down. And like, even though it's going up, gravity is still having an effect on it as it rises. So I would go with B.
Alright. Next problem.
Problem 2. Suppose you are trying to get a hockey puck to travel along the track as shown in the picture. At the beginning, somebody hits it in the direction shown. Let's say example A. Okay, question 1, part A. In which direction does A, B, or C does somebody hit it so the puck make its first turn? Question 2, which direction does A, B, or C does somebody hit the puck so it makes the second turn? In part A, I'm thinking about it. So as it starts, it kind of makes a slight turn,